Alright. Bar of Zevs, привет. Hello. Thank you everyone for coming. Thank you for having me. So I was already introduced, so I will just quickly run from the slide. So I am a developer from some early childhood. One of the things I remember, my earliest childhood memory is me writing Cheburashka for myself using circle commands in BASIC. I am Go developer since 2011. Oh, that was way before 1.0. I'm occasional, not even occasional, I'm a contributor to PostgreSQL by accident. It turned out I reported a bug and they fixed it and credited me for reporting a bug. So now I'm officially a PostgreSQL contributor. I worked at small companies, startups, large companies. I worked at Percona, I worked at Sidera Labs. Sidera Labs is a fun company that makes an operating system in Go. But then I left and co-founded FairDB with two other ex-Perconians, and I'm serve as CTO. So my talk is mostly about PostgreSQL, so don't worry, it's not a product placement talk, but we need to talk about FairDB a bit to understand the rest of the talk. So as you probably know, there is a database called MongoDB. And MongoDB uses its own protocol and its own data type called BSON, which can be think of binary JSON, but not really. They use custom drivers, custom everything, and then applications use it, and they generally love MongoDB until they don't. And there are some problems with MongoDB. There are some scalability and performance problems. Maybe it's better to do in the end. No? Is it possible to switch off the light? And they changed the license. So for some use cases, MongoDB is no longer available. It's no longer open source. So our idea is we just replace MongoDB with FairDB and everything works as before. But of course, if you want to make our own database, we have to spend at least 10 years writing a reliable storage layer and durability and all that. So instead, we decided to use PostgreSQL as our storage, and we act as a regular PostgreSQL client. We use regular SQL. We call DocumentDB extension function. So DocumentDB is extension recently open sourced by Microsoft. It's more or less an open source version of Cosmos DB for MongoDB. We partnered with them and worked together for about a year to open source it. The previous version used JSON and JSONB to store data in PostgreSQL. Now it's DocumentDB. For this talk, that's not important. It's just a regular PostgreSQL client. So why we choose PostgreSQL? As I said, writing a reliable and durable database takes a lot of time, and PostgreSQL is already there. It's a very mature database. Many companies already run it side by side with MongoDB sometimes, and the idea is that if they already run it, it would be easy for them to switch, and they could avoid having some people who need to have an expertise in MongoDB. So it's always easier to run one database than two different databases with very different performance characteristics and experience needed and all that. It's a huge open source project and huge community, very active. Not very easy to participate, I would say, but very easy to benefit from. And as I said, like reporting patches is easy. And it's extensible. So that's the most important part for this talk. So I'm going to talk about how we extend PostgreSQL. But I want to say that what we don't do, we didn't write FairDB as PostgreSQL extension. FairDB, yeah. So FairDB is separate process. It's a proxy which acts as proxy for MongoDB clients and then calls PostgreSQL. It's not a PostgreSQL extension. So why is that? In one sentence, it's because they scale very differently. So PostgreSQL has state, of course, it stores data. It has to have state, and FairDB is stateless proxy. You can shut it down and nothing will be lost except for client connections that could just reconnect to another FairDB instance without a problem. It's much better at handling MongoDB connections. So not because they're MongoDB. PostgreSQL, of course, can't handle MongoDB connections, but PostgreSQL uses one process per connection. It forks a new process for each connection, and that doesn't scale as well as Go routines. So FairDB is written in Go, And under the hood, it uses a few threads and uses much more coroutines to handle those threads. And therefore, we create one coroutine per client connection, and that scales much better. There is no need to use anything like PG bouncer or some other solution for PostgreSQL. You could just use FairdB. And we have some ideas. For example, you can use FairdB to generate vector embeddings for AI. And of course, having GPUs on PostgreSQL nodes would be a bit strange. So you can have normal servers, let's say, for PostgreSQL machines and different servers of FairdB, and they scale very differently. So all in all, I would say having FairdB as a separate process makes a lot of sense. But earlier this month, I was at FOSDEM. That's the biggest European open source conference about everything. It's like huge, a ton of people, no registrations, takes the whole university campus. And there was many tracks about different databases, open source databases, of course, not MongoDB. But we had a stand there and we talked with a lot of people, some customers, some users, some just people interested in open source and MongoDB replacement. And they had this, a lot of conversations, and they asked, like, okay, first, are you a fork of MongoDB? No. Are you a PostgreSQL extension? No. Why is that? And then I explained all that. And I had this guy who said, well, it would be nice if FairdB would be a PostgreSQL extension. I asked him why. And he said the thing that kind of shook me to the core. He said it would be easier to sneak a PostgreSQL extension to production. So it turned out he works at a really big database company, which has a lot of people, a lot of database machines, a lot of servers, a lot of administrators, and they have all extensions essentially pre-approved, or at least on a fast track to be approved. And if they want to run some other software, which is not a database, that's essentially a separate team. I worked at different companies. I worked at Microsoft, which is a huge company. I could understand that logic, even I don't think it's a good logic, I at least could understand it. So what can we do? So in theory, we could somehow make FairdB run next to the PostgreSQL. It would be an extension or something that's still open, but essentially we don't change anything about that architecture. We still connect to PostgreSQL using PostgreSQL protocol and SQL. We are not like trying to share memory or communicate via some other way, but we just run it close to PostgreSQL. And then how can we do it? So the idea was roughly that. So I know that FairdB is written in Go. Well, I know that because I wrote. Go is a very different language from C. PostgreSQL is written in C. It's garbage collected language with runtime, have very different binary interface, etc. In general, it's not compatible with C. But it has something called CGO. If you know what FFI is, it's kind of FFI implementation for Go. It's a way to generate some code to build a bridge between C and C compatible languages and Go. And there's an option to run FairdB as a Go library. So FairdB, as I said, is a separate process, but if you have a Go program, you can run FairdB inside that program using FairdB just as a library package. There are some use cases for that. They made a bit more sense in version 1 when we supported, for example, SQLite as backend, and then you can have the whole database inside your program without Postgres, without any external process. In version 2, it's a bit less sense, so we removed it originally, but then someone came to us and asked, hey, could you add it back? And well, it's not hard, we added it back. So we had roughly this plan. So we used Go and CGO and some duck type in C. Then we have a question mark. I'm going to talk about it a bit later. And then we will have profit because we are a small company, small startup. We could never say no to any customer who works at a big company and want to try to use FairdB. So I started looking, okay, how we are going to actually extend PostgreSQL. They found something called background workers or background worker processes. And I'm going to just quote documentation because I think it gives a good overview. PostgreSQL can be extended to run user-supplied code in separate process. Such processes are started, stopped, and monitored by Postgres, which permits them to have a lifetime close link to the server status. So basically, you provide some code, and it runs, it's being run by PostgreSQL. And if PostgreSQL is restarted, your code will be restarted. If PostgreSQL is stopped, your code will be stopped gracefully. You can get a signal, handle signal termination, all that. In a sense, it acts as like a process supervisor. A bit strange to use PostgreSQL for that, but essentially that's possible. Those processes are attached to PostgreSQL shared memory, which is not useful for us, but that is an option for other normal database workers, and have an option to connect to the database. So in our case, it's not very useful, but just keep in mind if you write something which wants to run inside PostgreSQL. For example, some internal facilities of PostgreSQL actually use the background worker architecture for example, logical replication is actually implemented as a background worker process. And also this process would link libpq to connect to server as normal client. So again, we don't actually use libpq because it's written in Go, but the idea is essentially the same. We use a regular PostgreSQL driver to connect to PostgreSQL. I want to stress out that background workers are not extensions in the sense of the word as PostgreSQL uses it. So PostgreSQL has many different extension points, and the most common one, of course, is extension, which is unfortunately uses the same word. But generally, you create extension by creating a shared library, writing a control file, create extension statement, then you have to handle upgrades somehow, etc. Background worker process is just a shared library. You specify in shared preload libraries. Postmaster process, which is a main process of PostgreSQL, preloads it on the startup. Then it registers background worker from that library. And then it forks a new process to run this background worker in the background. So what we are going to do? There are a few points that we need to implement, just a few C functions code. So first of all, we need to implement something called pginit. It's an entry point to any PostgreSQL extension or background worker process, basically in any shared library that you've specified preload. So that function in our case should just call register background worker with some parameters to specify what background worker actually does. Then that function, again, still written in C, it needs to do some setup, for example, setup signal handler, and then it just calls a Go function through Cgo. And our Go code also quite simple, it just adds VerDB as a Go module. So how it looks like. So that's the first part of it, just background worker. Details are not really important, I just wanted to show the size of this code. It's really all you need to do. Create a variable, zero out memory, specify name, specify that you need shared memory access. Again, we don't actually need it, but there is no way to avoid it, but it also doesn't hurt us. Then we specify that we should start once recovery finishes. That means that if PostgreSQL wasn't terminated clearly, it starts recovery process on the next startup. And only once that recovery is finished, it's being started. We specify it should never be restarted. Also, we could specify that it should start every 5 minutes, 5 seconds or so. And then specify name. And the last thing is we specify actually a function name that performs the actual work. And then we just register it. So how that background main function looks like? It's also quite small. The only thing it does, it unblocks signals. So our Go code could handle the signal. And then it calls a background worker main, which is a Go function. And there is a lot of magic on top. So you can see this PG model magic defined, and Cgo expert. Cgo expert is generated by Cgo part and then some includes. But essentially, you just need to call one function. And Go code is similarly small. You have some magic comments on top. Background worker main is actually our main code. I just omitted it, but essentially that's a normal regular Go code. We import VerDB model and start it. And then main function should be present, but it's not actually being called. It's just a limitation of the build process and thinking process. And simple makefile. If you're familiar with Go, you probably know how to build C libraries, C shared libraries. If not, you can see that like we just need to specify some directories, a shared flag, and then build FairdDB as a shared library, and then we just copy it into PostgreSQL lib directory, and that's it. So that's the plan. I showed the Go code, I showed the C Go wrapper, I showed the duct tape that we need in C. And now we need to talk about the second part, this question mark. That question mark is drama. The problem that the code on previous slide doesn't actually work. So there is a bit of backstory. So I did the first prototype at the FOSDEM, and then just checked that it could work. Everything was fine, and I was traveling back. I was very, very sick. And maybe because I was sick, I did notice that it didn't actually work. Maybe there is some other explanation. I have some theories, but in practice, the code just hangs. So it starts loading, it starts some initial work, and then just stops working. Nothing happens. FairdDB is not working inside that environment. And I don't know why. I tried everything. I debugged it, couldn't make it work. So what I tried, since the beginning of the February and today, there was a new Go release. Okay, I tried the previous version of Go, didn't help. There was a new PostgreSQL release. I tried a different version of PostgreSQL, didn't help. I tried to change some compiler or linker flags, didn't help. Signal handling, I just removed it all. Just I showed on the slides, there is no signal handling at all, didn't help. There are some specific problems about PID1 when you have your process running as process with ID1, it gets signals, the signal handling is a bit different. What happens with child process that terminate is a bit different. I tried it on the host machine, tried it inside Docker with PID1, didn't help. And that's where I was yesterday, actually. So like one day before the talk about how to use Go background workers in PostgreSQL, it didn't work. I was lying in bed already. And I actually figured out what the problem is. I woke up, went to my computer, and yeah, it actually was the problem. I updated the presentation to allude it to in previous slides, so maybe someone already figured it out. Let's see. So what happens that PostgreSQL starts and then preloads all shared library files, as in preload shared library setting. When shared library of the Go program preloads, it starts a runtime. So Go, the language has a runtime, including garbage character and whatnot, and it starts its runtime in separate thread. Then PostgreSQL forks a process to start our background worker. And what happens that we fork a process that has threads. And if you know anything about Unix programming, you know that threads and forks don't work together. You essentially can't fork a process with threads. So one of the core Go developers said this in the somewhat related issue, and that's what I remembered when I was in band and figured it out, yeah, and found it, that, yeah, that's the case. A multi-threaded program cannot safely call fork. This is a general rule, not a specific to Go. A single-threaded program that's DL open is a function to open dynamic library. In the Go shared library becomes a multi-threaded program. At that point, it cannot call fork. So what can we do? There are essentially two options for us. One of them is to wait for multi-threaded PostgreSQL. There is an effort that started, I think, last year, actually, no, 2 years ago. There is a wiki page about it, and they are slowly walking through the PostgreSQL code, remove all global variables, global state, make it work with multiple threads. And they want to do it because it would make handling of multiple connections much better. You don't have to create the whole process. For connection, we could create a thread which is much more lightweight. Another option is to change PostgreSQL. So as I described, PostgreSQL preloads all libraries, and we could change it to actually fork the worker process first and then load the shared library. That would require us to have some different kind of extension. So PostgreSQL could be aware that this library represents a background worker without loading it first. So it could first fork a process and then load the library and everything will be fine. And it doesn't seem there is any other way, right? So this morning, I had an epiphany. So let's talk about, again, I repeat it for the third time, I guess, how PostgreSQL works with shared libraries. What it does, first it preloads all libraries in this list. The function for that is called DLOpen. Essentially, it calls DLOpen all those libraries, loading them, and that's what creates the process of creating a separate thread for Go runtime. The second part is it registers background worker. It lookups the symbol. DLSym is a function name that lookups the symbol called pginit, and then calls this function. As I showed on the previous slide, that's a function that registers our background worker. And then it starts background worker by forking the parent process and then just calling the function, which is in our case called background main. So what can we do? We could do the same. And where we are going to do the same? In another background worker. So we create another background worker. They are called FairyDB loader, which loads FairyDB shared library using DLOpen, finds an entry point using DNSym, and background worker main is the main Go function, which implements the logic of FairyDB. And then we call this function. The important part is that FairyDB loader runs already in a separate forked process. So it's already background worker, is already forked by PostgreSQL. There are no threads. So we are in a safe environment, and we could actually start creating threads in a new process that doesn't affect the main PostgreSQL process. So essentially, that's the old background main function I removed. The rest of it, we just call the function. And instead of that, we do that. We open the library file with some parameters. We do a totally safe typecasting as in C, as usual. Then we call this function, and that's it. And on any error, we just return from that function, call del close to close the library, and exit the process. And it works. So just a few hours before the talk, I managed to make it work, which is a great achievement, I would say. That's, if not the best timing. So now, what could you get from this talk? What profit do you get? Because what I get is like, well, we'll potentially have a customer. You now know that PostgreSQL has background workers, if you didn't know before, and how they're useful. You can run some stuff inside PostgreSQL process that could interact with PostgreSQL or not. It doesn't have to. Like in our case, it can be used to run any kind of code, including code that normally can't run inside a C program, even if like threads are created or there's some virtual machine, for example, or something like that. But sometimes you need duck type, and if not enough duck type is applied, then you should apply some more. And then everything will work. So I'm still working on that. The pull request is there on GitHub. It's not merged yet, and it wasn't even reviewed yet. I expect my teammates on Monday would be very happy to see it. Some insane C code and FairyDB code base. Our repository is public. It's open source. Please start it. GitHub starts are very, very important. You can learn more about FairyDB on the website, and that's it. I'm ready to answer some questions. Thank you.
Can your found path to the system be considered a safety issue?
So I would say normally no, because all those processes are used just normal, regular Unix permissions. So the normal user could not, for example, just copy a file to the shared library folder of PostgreSQL. Second, in practice, all those things are already run in containers, so they're isolated on top of that. So, I mean, everything that you run inside PostgreSQL runs with PostgreSQL process permissions. generally it doesn't have a lot of permissions. So I think that should be fine. Okay, other questions? Okay, a lot of questions.
If we look for reason why we do it, to provide for enterprise team to sneak code inside the Postgres, then it looks like more the whole in this process because we integrate some code right inside the Postgres process.
Yeah.
It's almost dangerous.
Yes.
So we don't put it wrong.
So the thing is, the technology is perfect. It's people who are the problem, right? Yeah, I mean, yes, that's not the best solution. I described that I think the FairDB generally should be run as a separate process. That would be the better. But some people has so broken process and they would prefer to run FairDB despite that. So yeah, we provide a solution for them. Are they going to be happy with it? I don't know. We'll see.
But by design, Postgres have the right isolation for this process, or not it's a site.
Kind of. So they fork the process. So the parent ID is being inherited. Then they try to drop privileges, but there is not a lot of APIs for that. So for example, background worker could not specify, okay, I need less privileges. But also at the same time, it could just call this code to drop its own privileges.
And you have all of those files, whatever, you can do it.
Yeah. I mean, it's not the way to run untrusted code inside PostgreSQL. That's 100%.
But I look from enterprise security team view, it's not required.
Yeah. But then again, if all PostgreSQL extensions are pre-approved, as the guy told me, then actually, yeah, that's a good question. But I probably couldn't provide some specific examples, but they run some weird stuff inside PostgreSQL already, so maybe that's fine for them. Okay, more questions.
If you would be a king of Postgres kingdom and knowing all of that, would you do anything differently?
So, I mean, it's easy for me to say, right? So, like, I would say that using threads is probably a better idea for applications like PostgreSQL. At the same time, when they started, I don't think there was even an API, portable API for threads at all. So that might be one of the reasons. And then Postgres process provide better isolation. And so that was the best available solution for them back then. The fact that all code is written the way that assumes that everything is global and shared and global variables everywhere, again, that's kind of a historical reason. So of course, if I would be like not allowed to, but it would be possible, then I would rewrite everything. But then everyone would rewrite everything, and we will never make progress because everyone will be rewriting everything. Yeah, providing some better ways for background workers might be also possible. But then again, background workers is something that is the simplest common solutions for all kinds of workers, because like it just runs any code and then code can do everything. They also use that as the same infrastructure in PostgreSQL itself. So maybe that's one of the reasons why they do it this way.
But they are still going for the multi-threading anyway.
Yeah, but it will take years. Yeah. Other questions?
What can be other process for using
Yeah, so the thing is, background processes, they have access to PostgreSQL internal. So PostgreSQL architecture doesn't have any kind of public and private API symbols and whatnot. It's just a big C program where you can have access to everything. They have special API called SPI Server Programming Interface, which allows you to call SQL queries, transactions, have access to all the details need to. So it provides a lot of flexibility. For example, you could have background process that have a deep audit of all queries that are running. And that generally is not possible with regular extensions. So regular extensions have just some specified extension points. But if you want to check like everything, there is pretty much no alternative to background workers. Then, of course, you are in the mercy of the C, and then you have to do everything in a safe way so you don't crash the process, but it's possible. And also, yeah, you can run any kind of code with HL, even if it's as weird as FireDB. Why FireDB is written in Go? Well, the honest answer is because I know it's the best. But more realistically, yeah, from the very beginning, we knew that we are not going to write our own backend, like storage, for example. And Go is good at handling network connections, getting bytes in and out of the network, calling some other process. Yeah, there is nothing better, I believe. Doing the same in something like Rust would take much more time. There was actually some project, I don't even remember the name, that more or less started at the same time as FireDB is. It was written in Rust and then it was abandoned. I could only speculate why, but maybe language also had something to do with it because they were just making progress much slower than we do. Okay. What would be better? Well, it would be a safe language. So when I was writing that, I had some segmentation fault, something that would not be possible in Go. That definitely is much safer language. It would be better at handling network connections. Some things would be significantly easier. Some things would be significantly harder. So I would say C was the best option available for them back then. Again, Go is didn't appear for about 15 years after PostgreSQL started, so that's a lot of time. Right now, something like a real database like PostgreSQL, I think Rust is a better language there, or yeah, probably Rust. But then again, it will take a long time to do it. How many users? Well, I don't know. It's open source, so everyone could run it. We have some telemetry, which is we talk a lot about, and we try our best not to try to hide it. So we assume that a lot of people actually disable telemetry in FireDB, but of those who don't disable, we have thousands of installations. How many users, how many of them are companies or individuals, we don't know. Mm-hmm.
And for example, we need to grade to PFTP.
Mm-hmm.
Is there an option to add a Postgres in sharp mode? Or maybe try to think with space?
Yeah, not yet. So that's something we are thinking about. So we had some plans and ideas how to do both sharding and replication. Then DocumentDB and their partnership with Microsoft kind of threw those ideas away. They plan to introduce some form of sharding into DocumentDB itself. We have some research about so basically how we could make it work if we implement oplog, and then MongoDB is happy with our oplog implementation, so it doesn't know the difference and connect to us as to MongoDB, another MongoDB server, and then it could all work. So far, it's just early research prototype. That should be possible. One thing we want to enable doing before that is not sharding, but you could connect to MongoDB as a replica and then get all the data without stopping MongoDB. That should be easier, also requires block implementation, but that's something that probably is coming this year at least, maybe in a few months.